Hi everyone, my name is Yuttana Tuknoy from the Office of ADOM for Peace, the Ministry of Higher Education, Science, Research and Innovation, Thailand. Today I would like to give a talk on the topic of natural and artificial little declines in sediment and seawater from the Gulf of Thailand. Here is the content of my talk. I'm going to start with the introduction. I'm going to briefly introduce to you about the important sources of radionuclides in the marine environment for your better understanding before we move on to the materials and methods that we used to prepare and analyze the radioactivity or radionuclides in the sample we collected from the Gulf of Thailand. And then we move on to the results and a short discussion before I end up my talk with the conclusion. Here is the introduction part. In fact, there are three main important sources of the radionuclides in the marine environment. Firstly, some of them are produced from the natural. We can categorize them into two different sources. Firstly, we call them the terrestrial radionuclides, which are the radionuclides that produced at the same time when the Earth was created. These radionuclides uh, consist of the potassium-40, radium-226, thorium-232, and so on. The second one is the cosmogenic radionuclides, such as the carbon-14, beryllium-7. They were produced by the interaction of the cosmic ray and the elements in the atmosphere. Once they are produced in the environment, they can deposit and accumulate in the coastal and marine environments. So they can be detected in the seawater, sediment, and also the marine species. The second source is the from the nuclear activities. Uh, here is the list of the uh, artificial radionuclides produced from the nuclear activities, including cesium-134, cesium-137, iodine-131, strontium-90, tritium, and so on. When we talk about the nuclear activities, those activities include the nuclear testings, even though they occur in the past, but some of the radionuclides still remain detected in the environment. Nuclear power plants or power station also the main source of the artificial radionuclides to be released into the marine and coastal environments from their routine operation on a daily basis. It has been widely known that there are more than 100 nuclear power stations in our region. It means that our marine environment might be facing an increase of the artificial radionuclides from the routine operation of those operating nuclear power stations. In addition to the historical nuclear testings and the nuclear power station in the region, in the near future, we are going to have the floating nuclear power plants at this point in time, is being constructed by some countries, and they have the near future plan to operate the floating nuclear power stations very soon in the marine environment in the ocean. Apart from that, we also have the which is of the nuclear power vessels in our region. on the routine basis. So they might be considered as a potential source of the artificial radionuclides in our marine ecosystem. Obviously, nuclear power accident, especially in 2011 in Fukushima in Japan, it caused the huge concern over the radioactive contamination in the sea and ocean because they shortly after the accident they accidentally and intentionally released the radionuclides into the marine environment, causing the radioactive contamination in several countries. So more attention uh, need to be placed on the monitoring of those artificial radionuclides from the latest nuclear power accident. In addition to the natural radionuclides produced by the natural phenomena and nuclear activities, some of the non-nuclear activities also have the potential to uh, concentrate or increase the radioactivity of the natural radionuclides, for example, radium-226, thorium-232, and uranium-238 in the nearby marine environments from their routine operation. Those non-nuclear activities include the coal-fired power plants, coal ships, offshore oil rigs, petroleum refinery. By having said that, we have the objectives to determine radioactivity from both natural and artificial radionuclides in seawater and sediments. We would like also to establish the National Marine Environmental Radioactivity Database and mapping. Lastly, we would like to share our, analyzed data with the regional and the international databases. Here is the materials and method part that I would like to talk a bit about the process that we carry out to analyze the radioactivity in the marine samples. I would like to start with the sampling locations, and basically the sample collection uh, was carried out between August and September 2018. We collected 38 seawater from 38 stations and 71 sediment samples from 71 stations, including 24 stations for Cambodia. We took 10 liters of seawater. We get them filtered, and we took 1 liter of seawater to analyze the gamma emitting radionuclides, including potassium-40, radium-226, and thorium-232, using the gamma spectrometry with the counting time of 20,000 seconds. Secondly, we analyzed the cesium-137, which is one of the artificial radionuclides of interest in seawater. We also use the 10 liter of seawater. We use the ammonium molybdophosphate or AMP technique to prepare the cesium-137 to be counted using the gamma spectrometry with a counting time of 80,000 seconds. For the sediment sample, we took 1 kilogram of sediment from each location. We dry them and then we ground them into fine powder, and we pack them in the plastic container, and then we measure them with a counting time of 80,000 seconds using the hyperpure germanium gamma spectrometry. For this process, we measure again the gamma emitting radionuclide, including radium-226, potassium-40, and thorium-232. Here are the results and short discussion. And I'm going to start with the result of the thorium-232 in seawater and sediments. And we found an average of 0.89 becquerel per liter of thorium-232 in seawater. And we found a mean of 45.36 in becquerel per kilogram in the sediment sample. For those two results, when we compare to the previous studies, we found that our results are similar to those results from the previous studies. For the radium-226, we found an average of 0.78 becquerel per liter in seawater, whereas an average of 27.99 becquerel per kilogram was detected in the sediment sample. Again, when we compare to the previous studies, for example, the IAEA in 2016, and with the study in Malaysia in 2009, and we found that our results are in good agreement with those number from the previous studies that I just mentioned. For the potassium-40 in seawater and sediments, an average of 8.01 becquerel per liter was detected, and a mean of 407.11 becquerel per kilogram was reported. Again, when we compare the result from the present study, they are in good agreement with the results from the previous study that was carried out in the Gulf of Thailand by the Office of Atomic Energy for Peace. Moving on to the last radionuclide that we are interested in, which is the cesium-137 in seawater and sediments. We found a mean of 1.09 millibecquerel per liter and a mean of 0.36 becquerel per kilogram in seawater and sediment respectively. Again, when we compare with the results or figures from the previous study that was carried out to measure cesium-137 in the Gulf of Thailand, and they are not significantly different. Here is the conclusion of my research. Radioactivities in seawater and sediment from natural radionuclides are in good agreement with those previously measured from the Gulf of Thailand and other areas across the globe. Cesium-137 levels obtained from this present study are lower than those measured in the Gulf of Thailand prior to the Fukushima Daiichi nuclear accident. It means that uh, our marine ecosystem has not been radioactively contaminated or affected by the radioactive release from the Fukushima nuclear accident. A significant increase of radioactivity in the study seawater and sediment has not been observed. Lastly, all analyzed data being gathered to strengthen the National Marine Environmental Radioactivity Database and to share with the Asia Pacific Marine Radioactivity Database or ASPAMAT and the Marine Information System or MARIS maintained and operated by the IAEA. Thank you for your attention and listening.